Hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem, closest three sum. So what the problem is saying is we'll be given an array, okay, and a target, okay. And what we want to do is we want to find out three integers, right? Three integers whose sum will be closest, to the given target, okay. So which are these three integers in this example? So the three integers are -7, 8, 1. If you see, right? So what is the sum of these three integers? It is 2. Now in this case, it is exactly matching to the target, but it won't be the case for all the other examples. Okay. So here, if you see, which are the three integers -7, 8, and 1. Okay. So we have to find out three such integers. Okay. Now, how can we solve this problem? Okay. So the brute force, first, let's see the brute force approach. So the brute force can be to take three for loops. Okay. So one will start, the first for loop will start from this number, the second for loop will start from this number, and the third for loop will start from this number. So we can add, through these three for loops, we can find out the three integers whose sum will be closest to the given target. Okay. But this is brute force and it will take O of n cube, right? But now what is the expectation here? The expectation is O of n square. Okay. So how can we achieve this in O of n square? So what we can do is we can sort this array. Okay. How can we sort this array? So after sorting this array, what the array will look like? -7, 1, 1, 3, 8, and 9, right? So once we have sorted the array, what we'll do? We'll run a for loop, a single for loop. Okay. Let's say the pointer will be I, right? And what we'll do? We'll take two pointers then. So what will the two pointers? One will be L, which will start from I plus 1. Okay, I plus 1. Okay, and one will be R. Okay, which will always start from n minus 1, from the last element. Okay, from the last element. So what we are going to do? We are going to now, what we'll do? We'll take a current sum. Okay, what will be the current sum? A current sum variable which will take the sum of the three integers pointing at positions I, L, and R. So what will be I? What is R of I? It is going to -7 plus L. What L will be? R of L, it will be 1, and R of R will be 5. Okay. So what does the current sum give us? It gives us 3. Okay. So what we're going to do? We'll have a minimum variable, okay, which will be initialized with infinity. Okay. And what we're going to do now, we'll have current min variable as well, okay, which will be absolute of target minus whatever is the target minus current sum. Okay. Current sum. Okay. So what it will be? Absolute of 2, right? Target is what? 2, right? And current sum is 3. Okay. So it is going to give us what? The current min, it is going to give us 1, right? Current min. Now we'll check this current min with this min. Okay. Definitely we'll check if current min is less than this min, then update this min. Okay. We'll also take answer variable here. Okay. Which will initialize with 0. Now we'll compare this current min with this min. Okay. So definitely current min 1 is lesser than infinity. So we'll update minimum and also we'll update the answer with the current sum. Okay. Finally, what we want to return? We want to return the sum of the three integers, right? Which is closest to the given target. So we'll update this sum, the answer with this current sum 3. Okay, this current sum 3. Now what we're going to do? So yes, so we found one minimum. Now what we're going to do? We will now check. We'll now check if current sum, right? If current sum is less than the given target, right? If this is the case, current sum is less than the given target. What is target? Sorry. What is target? Target is 2, right? Target is 2, right? Target is 2. So if current sum is less than target, then we'll increment L. We'll increment L over here. Okay. We'll increment the lower pointer. Else if the current sum is greater than the target, then we'll decrement -R. So what we'll do is, for example, if current sum is less than target, right? If current sum is less than target, so we want to increase the sum. So what if current sum is less than target, then we'll increment L. So why will increment L? In order to increase the sum, right? Definitely if we increase L, right? So the chances are the next number, it is going to be bigger than this previous number, right? So the current sum will increase and will go more closer to the target. Will go more closer to the given target. Okay. And if the current sum is more than the target, then we'll decrease R in order to reduce this sum so that we can come closer to the target again, right? We can come closer to the target again. And that is why these conditions, right? That is why these conditions. So for example, now our current sum is what? Our current sum is 3, which is greater than the target, right? Which is greater than the target. So we'll decrement R. So we will update our R here. So R will point here now. R will point here. Okay. So now what are we going to do? Now again, we'll take the sum. We'll take the current sum, right? So what is the current sum? R of I. R of I is -7 again. Plus R of L, it is same 1, right? R of L and R of R. R is what? Now R is updated, right? So it is going to give us 8, right? So what will be the sum now? The sum will be 2, right? The sum will be 2. Now we'll check. Okay, the current sum is 2 now. So we'll calculate current min. So what will be current min here? So, sorry, current min, it is going to be what? Absolute of target target minus current sum, right? Current sum, right? That's what it is, right? So what we're going to do? So what is target? 2. Current sum again it is 2, right? The new current sum it is 2, right? Which is 0, which is 0. Now we'll compare. Current minimum is 0. Now we'll compare with minimum, right? Now it is lesser. The current minimum is lesser than the minimum, right? So we'll increase, we'll update minimum. Also we'll update the answer, right? What is the answer here? Current answer it is 2, right? Current answer is minus 7 plus 1 plus 8. It gave us 2. So we'll update the answer. Okay. So in this way, again we are going to check what? Again we are going to check if current sum is less than target. No, it is not less than target. Current sum is 2 and target is also 2. So again, we'll decrement R. Okay, we'll decrement R, right? So we'll go R. So R will pointing to here, right? R will pointing here. So in this way, we are going to calculate, or we are going to calculate the three integers basically. Okay. And what will be the time complexity here? So the time complexity is going to be sorting how much it takes? O of n log n, right? Of n log n, right? But again, will be running two loops basically. One will be the for loop and one will be the while loop for this L and R. Okay. So we'll see to the code. So overall, it will give us the time complexity of O of n square. So let's go to the code. I think you'll understand better after we code. Okay. So before going to the code, I'll request you to subscribe to my channel. Okay. Thank you so much. Now, okay. First I'll show the Java code followed by C++. Okay. So let's sort the array. Arrays dot sort. Okay. We'll pass this array. Let's call this array. Array. Okay. It's a very big num. So we have, and then what we're going to do? Once you sorted, right? So we'll have what? We'll have I less than, let's also have the length, right? N equal to array dot length. We'll say, okay, n minus 2 it will go. I'll explain why we are going till minus 2. Okay. Because, yeah, let's see why we are calling it minus 2. Now we'll take 2 pointers L. L will be I plus 1 basically, right? And R will be n minus 1, which will always be n minus, it will start from n minus 1. So that is why we have I equal to n minus 2, because L will start from the next of I, right? And R is covering the last element. So I need not go till the last element, okay, because R is still covering that. Okay. Now we'll have what? We'll have a while loop again, okay, which will run from L is less than R, right? L is less than R. Now what we're going to do? We will have a current sum. Let's call it, okay, current sum. And what it will be? R of I plus R of L. I've already explained this, plus R of R, right? We have our current sum here. Now we'll take two variables, int min. We'll initialize this with integer max value, which is nothing but we can say infinity. Okay. And int answer equal to 0. Okay. Now we'll check, right? We'll calculate our current min. Okay. We'll also calculate our current min, which will be what? Math dot absolute of target minus current sum, right? Target minus current sum. Okay. So this is the current min. Now we'll check if current min, right? If current min is less than min, So current min equal to, we'll assign, if current min is less than min, then we'll update our minimum, with current min. Okay, with current min. Also, we'll update our answer as well with current sum, right? Current sum. Because what we are saying is we have found a minimum, right? A closest element. We have found the closest to the target 2, which is lesser than the current min. Okay, so we'll update our min. Okay, so that this min will be the benchmark for the next current min. Okay, and we're also updating the answer. Okay, okay. Now what we're going to do, if we'll check if current sum, if it is less than target, also I've explained this, then we'll increment our L, right? Else what we're going to do, we will increment our or decrement our R as well. Okay. Now there's one more condition which we need to cover. It will be current min. If it is equal to minimum, right? Then what we are going to do is, if it is equal to minimum, then what we're going to do, see here we have node also. If there are multiple solutions, right? If there are multiple, return the maximum one, the one with the maximum sum. So what we'll do, answer equal to math.max. Okay. Already existing answer, will compare with already existing answer and the current sum. So why, for example, right? So we had found, for example, the two sums, right? The two, this current min, for example, minus, if the target was 2, right? And we found two answers. One was minus 1, right? Okay. For the three integers, for one of the three integers, it was minus 1. The current sum was minus 1. And for one, there was another whose sum was 1. There was another whose sum was 1, right? Whose sum was 1. Now both are closest, right? Equally closest to the 2, right? But it may be the case that the integers, yeah, right? The integers here, the sum is greater than, this is greater than minus 1, right? This is greater than minus 1. And that is why this case, right? We are checking here. If current min equal to min, then let's update the answer. Let's say the maximum sum, right? Maximum sum. So here we have the answer. Okay. So let me also now return the answer. Here you go. Okay. So here, let's compile now. Let's see if everything is working. Yeah. Let me submit it. Okay, the test cases seem to have passed. Okay, yes, they have passed. Thanks for watching. Please subscribe to my channel, like the video. Okay, let's quickly see the C++ code as well. Okay, so the C++ code. So here we are sorting the array. Then we are taking the size of the array. We are initializing min with integer max. Okay, and here we are going. We are having a for loop which will go till n-2. We have this L and high pointers, right? And here what we are doing is we are running a while loop from L less than H, right? We are taking the current sum. We are taking the current min. We are comparing the current min with the minimum. If it is lesser, we'll update the min with current min, and we'll also update the answer with current sum. Here, as I said, we are checking for if both are equal, right? Minimum. So we're taking the maximum, the maximum sum, right? The maximum sum of the integers, of the three integers. And here, if the current sum is lesser than target, we are incrementing L, right? And if it is greater, then we are decrementing H. Okay, so this is a C++ code. I hope you got the solution. Thanks for watching. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.